a sign from profound space, a planet that overcomes all presumption and a rush to another star. Imagine a scenario in which all that we assumed we knew about the universe is going to be broken. The James Webb Space Telescope JWST has uncovered mysteries so stunning that they could revamp the principles of life itself. Yet, is Proxima B really another Earth or a destructive snare in the immeasurability of space? The James Webb Space Telescope, frequently hailed as mankind's most developed eye overhead, has recently turned its gaze toward one of the most fascinating exoplanets ever found, Proxima B. This far-off world, orbiting the red dwarf star Proxima Centauri, has enamored researchers and enthusiasts alike since its discovery. Yet now, with the unrivaled abilities of the JWST, we are finally getting a closer look at this strange planet, and the discoveries are truly remarkable. Proxima B was first identified in 2013, but it was only after the James Webb Space Telescope came into the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing details that were previously hidden from view. What they found has ignited both excitement and concern. You see, Proxima B orbits its star at an unbelievably close distance, just 7.3 million kilometers away, which is under 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11.2 Earth days. What makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf, unlike our Sun, which is a relatively steady star. Red dwarfs are known for their volatile nature, frequently emitting powerful solar flares that can severely affect the planets orbiting them. Now, here's where things get even more interesting. The JWST has provided the clearest picture yet of Proxima B, and it has uncovered some startling features. For one, the planet is about 30% more massive than Earth, meaning it has stronger gravitational force. But what's truly stunning is the possibility that Proxima B is tidally locked with its star. This means that one side of the planet is in constant daylight, while the other side is forever shrouded in darkness. Imagine a reality where the sun never sets on one side, and the other side is plunged into perpetual night. This tidal locking creates a harsh environment for any potential life forms. The side facing the star would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question. Could life ever survive in such extreme conditions? The odds seem slim, but nature has a way of surprising us. Yet, the challenges don't stop there. Proxima Centauri itself poses a huge threat to the habitability of Proxima B. The JWST has revealed that the star is far more active than previously thought. Its powerful magnetic fields generate intense solar flares that bombard Proxima B with high-energy radiation. In fact, a flare seen in April 2021 was over 20 times more powerful than any flare ever observed from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some scientists argue that Proxima B's proximity to its star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life could find a way to adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such an unpredictable environment? Or is the planet doomed to remain a barren rock, essentially dead? As we continue to explore Proxima B with the James Webb Space Telescope, more secrets are sure to be uncovered. But one thing is clear. This tiny planet, for 0.24 light years from us, is far more complex and mysterious than we ever imagined. Could it hold the key to understanding the limits of life in the universe? And if so, what does this mean for our search for extraterrestrial life? Proxima B's dazzling secrets have been uncovered. One of the most stunning revelations was the planet's atmosphere, or rather, the potential lack of one. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B is constantly bombarded with solar wind and high-energy particles. Over time, this sustained assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B could still retain a thin atmosphere, perhaps made up of heavier gases like carbon dioxide or nitrogen, which could provide some level of protection from the star's radiation. The James Webb Space Telescope has given us the clearest view yet of Proxima B's surface, and what it has revealed is both intriguing and enigmatic. The planet's surface appears rocky, much like Earth's, but with significant differences. For example, the side of the planet facing Proxima Centauri is likely scorched by constant heat, creating a barren, desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland, with temperatures plummeting to levels far colder than anything encountered on Earth. Yet the most intriguing possibility lies in the narrow band of land between these two extremes, known as the twilight zone. This region, where day meets night, could offer more temperate conditions, where liquid water could exist. The presence of liquid water is, of course, one of the key ingredients for life as we know it. Could this strange place harbor a secret oasis where life has managed to thrive despite the harsh conditions on the rest of the planet? Another astonishing discovery came when scientists examined the possibility of water on Proxima B. If water does exist on the planet, it would likely be in the form of ice on the dark side, or perhaps small, temporary pools of liquid water in the twilight zone. But the discovery that shocked many was the potential for subsurface oceans, like those found on moons such as Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core or by tidal forces generated by Proxima B's close orbit of its star. If such oceans do exist, they would be an ideal place to search for life hidden beneath the planet's icy surface. But we must not forget the potential challenges. The magnetic field of Proxima Centauri is another factor that adds complexity to the planet's situation. Recent studies suggest that the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction could help protect the planet's atmosphere from being completely stripped away by solar winds, much like Earth's magnetic field shields us from the sun's radiation. However, the situation on Proxima B is far from straightforward. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and unpredictable changes in the planet's climate and surface conditions. These discoveries raise more questions than answers. If Proxima B has a magnetic field, how strong is it, and how does it affect the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive the planet's harsh and fluctuating conditions? And if life does exist, what form would it take? Would it be something entirely different from anything we've seen on Earth? Or might it share similarities with extremophiles that thrive in Earth's most hostile environments? A hostile existence, where life faces extreme challenges, is the reality on Proxima B. While the possibility of a habitable planet orbiting Proxima Centauri is tantalizing, the truth is far from welcoming. The James Webb Space Telescope has provided unprecedented insight into the challenges any potential life on Proxima B would face, and the picture is far from rosy. One of the main challenges is the planet's exposure to extreme levels of radiation from Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star with a much smaller mass and a far more turbulent surface. This star's proximity to Proxima B means that the planet is constantly bombarded with intense solar radiation, including powerful flares that can be up to 20 times stronger than those emitted by our Sun. These flares produce a lethal cocktail of ultraviolet and X-ray radiation that would be deadly to any life form, like those on Earth. The effects of this radiation are not just hypothetical. In April 2021, an especially massive flare from Proxima Centauri was detected, and it was strong enough to potentially strip away any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed by red dwarf stars and raises doubts about the likelihood of Proxima B being a sanctuary for life. Moreover, the constant exposure to such radiation would make the surface of Proxima B an extraordinarily inhospitable environment. Any water on the surface would quickly evaporate, and the planet's rocky landscape would be scorched by the relentless heat. The dark side of the planet, while not exposed to direct radiation, would be equally unwelcoming due to freezing temperatures. This extreme divide between the scorching day side and the frozen night side virtually rules out a stable, life-supporting environment. The race to reach Proxima Centauri is on. While the signal from Proxima Centauri remains a mystery, the possibility of actually reaching the star system has moved from the realm of science fiction to a genuine scientific endeavor. The Breakthrough Starshot Initiative, led by a team of visionary scientists and supported by prominent figures like Stephen Hawking and Yuri Milner, aims to send small, laser-propelled spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The idea behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp, into space. These star chips would be equipped with cameras and other instruments to gather data as they travel toward the Alpha Centauri system. They would be propelled by powerful laser beams, allowing them to reach speeds of up to 20% of the speed of light, making the journey to Proxima Centauri in just over 20 years. While the concept of Breakthrough Starshot is groundbreaking, it is still in the early stages and many technical challenges remain. Developing the laser technology to propel the spacecraft, building the tiny but robust star chips, and ensuring that they can withstand the harsh conditions of space travel are all hurdles that need to be overcome. Nonetheless, the idea of sending probes to explore Proxima Centauri and its planets is an exciting and ambitious step forward in humanity's quest to explore the cosmos. As we look to the future of interstellar exploration, Proxima B remains one of the most intriguing targets. Despite the harsh conditions that make it a difficult candidate for life as we know it, its proximity to Earth and its potential to harbor secrets about planetary evolution and the possibility of life in extreme environments make it a focal point of scientific inquiry. The James Webb Space Telescope has given us a glimpse into the planet's complex nature, but many questions still remain unanswered. Will we find signs of life on Proxima B? Or will it remain an enigma, a world that challenges our understanding of what is possible in the universe? Only time and the continued exploration of space will tell. But one thing is certain: Proxima B, with its mysteries and its potential, will continue to captivate the imagination of scientists and dreamers alike for generations to come. As we push the boundaries of our exploration beyond our solar system, Proxima B stands as a reminder of how much we still have to learn about the universe and the potential for life in the cosmos.